Hello, good morning, good afternoon, good evening. Welcome to No Food Live. I'm your host, Matthew Lange, joined by my co-host, Courtney Riggle. Courtney, you seem to be muted somehow. I'm not sure why, but that doesn't matter now because I'm still talking. We welcome you all to Season 3 of No Food series. We're kicking off our first episode today with a discussion about smart food sheds. How can we use data to make our food supply chains more resistant, more robust, and resilient to things like climate change, COVID, what have you, invading armies? For those of you who are new to our series, No Food is here to dive deep into the world of food informatics and the Internet of Food. We interview scientists, thought leaders, innovators, and we are learning, probing, exploring how can we make food systems more accessible, more diverse, and more equitable. Can we feed the world with the food we have now? Is it possible? Will technology help us improve access? Or will it further increase the divide between the haves and the have-nots? Those are kind of questions we're asking here today. But No Food Live airs on the third Thursday of every month. You don't have to remember that. All you got to do is click the subscribe button down below.
Hey everyone, so happy to have you join us on No Food today, or whatever day you may end up watching this, because all of our previous episodes are streamed if you don't get to see it live. We thank you so much for tuning in, and we want to hear from you. If you have ideas for new episodes or guests or any feedback at all, please just email us at nofood@icfoods.org, which we'll also put in the chat below, so you can just click it there. So, but on to today. Today, as Matthew is starting to say, No Food will explore how we can use technology to better understand and answer questions about our food system, such as, those very essential ones. What do we eat? Where does it come from? What do we produce, and where does it go? What gets lost along the way? How do food production and processing decisions impact the environment? And how can tech help us capture information to make smarter choices and make our supply chains more robust, more resilient from beginning to end?
Today's topic directly builds on a No Food episode that took place last season, Season 2, Episode 3 to be exact. We had DK Panda, the principal investigator of the new Icicle AI Institute. Dr. Panda was joined by Professor Beth Plailey and Dr. Patrick Huber, and we talked about this AI Institute and in particular, smart food sheds. Today, we've invited Patrick Huber back. As well, joining us is Dr. Michelle Miller from the University of Wisconsin, and together they will share more with us on what's happening with Icicle's smart food sheds, specifically that use-inspired science. That's your cue, Courtney.
Oh, well, I'm actually up here. I didn't see my own face. All right. And a reminder, when we say food shed, think watershed, not tool shed, Matthew. Watershed, which is a catchment, if you will, of the sources of food for a region. And a smart food shed is an approach that integrates the many functions in a complex system, from production to processing, distribution, food prep, all the way to diet and health. And it's looking to improve outcomes for the community across all these dimensions.
All right. Well, clearly, we are on our first episode of our third season, and we're still a little rusty. So, Michelle, who is sitting diagonal from me on your screen, will share some of the food flow work going on with the Smart Food Sheds umbrella, looking at how better data on supply chains and the transport of food is important for building resilience. Patrick, sitting below me, will discuss ties between food sheds and working landscapes, and how this new concept of an internet of conservation can be a key tool for making food sheds smarter and landscapes healthier.
So let's get started. So We're opening our conversation today with Michelle Miller, an economic anthropologist working on regional food systems as part of the University of Wisconsin-Madison Center for Integrated Agricultural Systems. And Michelle, it's such a pleasure to have you with us on No Food today. And this is our first time having you, I think, right?
Yes,
Yeah,
it is, and I'm excited to be part of the IC Foods team.
Excellent. Well, welcome. And now, Michelle, I know your work focuses on quite a breadth of topics, including agroecology, resilience, climate change, particularly looking at that ag in the middle or that regional ag piece, and then as well as transportation and supply chain aspects, which I think we'll get to a little bit today. But quickly, before you jump into your prepared talk, can I just ask you to share a little bit about your work? And this is very relevant with the National Academy of Sciences Transportation Research Board, because I know you've mentioned before that sometimes when you're at that meeting or those meetings, you're the only food person there. And so how important is it to better connect transportation with food systems, and what opportunities do you see there?
Well, the National Academy of Sciences Transportation Research Board is an amazing organization. It's been around, I just returned from their 102nd conference in Washington, D.C. There were about 10,000 people there. There are 17 committees who deal with IT issues, data, information, and planning. Needless to say, I couldn't attend even a fraction of the sessions that I would have loved to attend. But I did learn a lot about how to access some of those data. Some of the participated in some discussions about data sharing, model sharing. There was a lot of interest in open source, although I think that was only shared by some at those meetings. I think there were a number of people who were in the private sector who really prefer to keep their proprietary information, data information and modeling close to the chest. It was a wonderful chance to meet a lot of the kind of key people keeping track of some of these things and understand kind of where they're at and thinking about ontologies and knowledge graphs and things like that.
Great, thank you.
So I guess I start. You ready for me?
We're ready.
Okay. So a couple years ago, I got asked to be part of the Icicle project, which you all have learned a little bit about. And, you know, this idea that we are working together to democratize data and models really appealed to me because this inability to access data and information from those data has really made a big difference in the ability of small businesses, emerging businesses, to serve their communities. Because they don't have those data, they aren't able to make the kinds of changes and provide the kinds of services that they'd like to. So I'm part of the Smart Food Sheds use case. IC Foods is there, UC Davis, Ohio State, and our University of Wisconsin team participates as well. So we have an increasing uncertainty in food systems, and this increasing uncertainty requires better information. One of the things that came up last week at the conference was how data rich we are. I mean, really, it's an embarrassment of riches. The US has more data than probably anywhere else in the world on which to make some real key changes. And it sets us up to be transformative. We could really transform the food system globally by doing it here. So some of those uncertainties are changes in the global water cycle, changes in settlement patterns, changes that we're seeing in how food is transported. One of the things that I picked up at the Transportation Research Board meetings a couple of years ago were how many companies are moving from point-to-point distribution to hub and spoke distribution. And this really is an effort to regionalize transportation to reduce fuel use and improve labor conditions. And I think that the food system has yet to really participate in building this regional infrastructure necessary for regional food movements. Also, you know, my hope is that we also see a change in cropping systems as a response to all these other changes, and also to improve environmental quality I've been working in sustainable ag since about 1980, and we'd love to see agroecology really take off here in the States. So just a quick reminder, of course, we've all learned about supply chains throughout the COVID period. And really what we're looking at is material moving from production to consumption, financial movements from the consumption point to hopefully the production point. But really, I think a key piece is the movement of information and how do we improve that flow of information. I was part of a research team that worked during COVID to understand what was happening in the food supply chain. And we looked at regional food systems in California, around the Los Angeles region, Minnesota, Wisconsin, with the Minneapolis St. Paul as the urban hub. And then we also looked at Florida, a number of counties in Florida. And on this slide, I've got some of our findings from comparing California and the Minnesota, Wisconsin area, or I should say Los Angeles and Minneapolis areas. And you could see that California or Los Angeles really was impacted hard by COVID, while Minneapolis was not hit as hard, and in some ways even improved during that time period. So it's these sorts of data that I think like little data sets that are out there in various research projects that would be wonderful to start to combine into a bigger picture. Another project that I'm part of is looking at the geographic network for food flow across the United States. We looked specifically at perishable foods, and we had public data from US Census Bureau, and it was modeled then by the Bureau of Transportation Statistics. And then we had a modeler at University of Illinois, Megan Konar, who downscaled that information to a county level. And then we applied degree centrality analysis to understand what kind of concentration was going on in the network. So on this graph, all the areas that are blue are kind of underutilized in terms of food flow, and all the areas in red are overutilized. And you can see how important California is, and Southern California is, in food flow, as well as Nebraska, Arkansas, Iowa, Illinois. And you can also see where there are counties that are not participate, even though they're adjacent to areas that have very high flow of perishable meats, that they are not receiving, they're not participating in that flow. So those are primarily rural counties that do not have access to that incredible flow coming out of those, what I call brittle counties. So this is the results from looking at perishable processed foods. And in Wisconsin, that's primarily dairy. In other parts of the country, it could also include processed vegetables, frozen vegetables, and fruit, for instance. And you can see that the blue areas are, again, the wheat areas that are not part of the flow, and the red areas are where we've got extreme flow. And you can see that this perishable processed foods are less concentrated than processed meats. The point here is that there is a lot of public data that's just not being put into any kind of shape that someone can use in a planning process. And this is just a tip of the iceberg in terms of data that's out there. Here's another example. This came from the Transportation Research, TransSearch. Many of our state DOTs, Departments of Transportation, pay money for this proprietary modeling data or information. And it has both US Census data and proprietary data mixed to come up with this. We wanted to understand what was going on with rural food flow. And so because we're a state agency, we were able to use the TransSearch data. Normally we'd have to pay quite a bit of money to have access to that TransSearch data. But because we were connected through the state. We were able to use it from our state DOT. So on the north end of this is the state of Wisconsin, and on the north end is Lake Superior. So it's a very rural part of the state, and the red areas are all showing that there's very low wholesale perishable distribution, less than a pound per person coming through traditional means. Now, these areas may be receiving food through unconventional means, but they are really not part of the food flow in the United States. They've really been left behind. Part of this is lack of infrastructure, no cold chain, warehousing that can make it possible to move product into those areas. But it's also concentration in data and information. By the way, one of the things I learned at the conference last week was that TransSearch is a product of IHS Market, which was just sold in February of 2022 to Standard & Poor's. And so even the proprietary data and modeling has become concentrated. This is clearly an issue. We're seeing reports on digital business ecosystems and how this lends market power to companies like Amazon, Kroger, Target, Walmart. All these companies are using these data and information modeling to make decisions to improve and increase their market power. I covered some of this in an article that came out in 2021 entitled "Big Data Information Asymmetry and Food Supply Chain Management for Resilience." Even the National Grocers Association are understand what's going on. There are about 21,000 independent grocers around the country remaining. There used to be quite a few more, but these practices are really hurting the entire food supply chain, not just the grocers, but also mid-size and small producers who are trying to participate in wholesale food sales, but maybe at a very small scale. So that's my presentation. I understand Patrick is next up.
Oh, before we get to Patrick, I have so many questions, and I'm wondering if I'm gonna just, if you don't mind, go back to a couple slides. This one here, I just want to make sure I'm understanding this, and that our audience is understanding this. And if you don't mind, we're just going to sort of take a little ride back through your deck, because thank you for such a great talk and information. I think that there's a lot of people who just it's so important, and this doesn't make the news, right? So that's part of the problem. We see one grocery store buying another, and we don't necessarily know what that means. We see one meat company buying another. We don't necessarily know what that means. And here I am looking at this slide, and you had said something that caught my ear about Minnesota perhaps doing better, but based on these statistics in COVID. What did you mean by that? Are you talking about the production ag area? Is that what you're looking at?
And in the processing and manufacturing sectors, I noticed as we went through the slide deck, I noticed that all of the numbers dropped off this graph. I have them on the slide in my PowerPoint, but they, for whatever reason, didn't translate here. So one of the things we could see was throughout the quarters of 2020, we could see a kind of a drop in production sales, food-related sales for production ag in California. So we've got people reporting anywhere between a 0% drop to a 57% drop in Q1. Q2, we had an 11% increase reported, but also an 80% drop, which ends up being about averaging to about 42% drop. By Q4, we saw a 10% drop in production ag, minimum 10% drop reported, all the way to a 70% drop. And then that's in the Los Angeles area. In the Minneapolis region, the set of counties we looked at there, we saw as much as a 34% increase in Q2. We saw an average increase in Q3 of 10%.
But when you're talking about production ag in California, it's very different commodities than the production ag in Minnesota, Wisconsin, right?
Well, it's not only commodities, but it's also timing, right? And it's we're looking at irrigated desert agriculture going on throughout a 12-month season, whereas in Minnesota, Wisconsin, our prime season is Q3.
Right.
So that definitely has an impact.
Right.
And we were asking, we had a whole series of different kinds of businesses taking this survey. So it wasn't just large scale, it was some large, some small, trying to get a kind of a general idea of how people were doing. Anecdotally, we heard in our region, in Minnesota, Wisconsin region, that a lot of people were joining CSAs, were going to farmers markets. The farmers markets were able to find a way to stay open. So all of those food market channels were doing just fine. Grocery stores were, had taken on safe practices, and we're seeing an increase in sales as well, which was unexpected.
Okay, let me just ask you about one, maybe two more slides. It was for me on my screen. The legend here is just a little bit small, and I was listening to you, and you were talking about red versus blue, but there's different shades of blue, and there's pink, and I just wanted to understand. I see maybe high, low.
Yes.
Can you explain what those things mean?
Yeah, I kind of rushed through these slides.
That's okay.
High cluster means that there is those counties are connected to one another. So there's probably like a super high clusters, and then the surrounding counties that are also somewhat high. So there's some influence on each other there. And so the light blue and the light pink are the high and the low. And then the red counties bright red counties are high-low outliers, and then the bright blue counties are low-high outliers. So for instance, I'm not sure what county that is down at the southern end of California.
Yeah, it's Imperial County.
Okay, so they are really close to high food flow in the counties around it, but that county itself has relatively low flow.
What do you mean when you say low flow?
They probably don't have much in the way of processing or warehouses or stores that are buying a lot of product. It's kind of akin to in an inner city situation where you've got a lot of people who are probably very poor living right next to food warehouses.
Interesting.
So I think that's kind of similar. So that's happening in rural areas as well as in urban areas where there may be food nearby, but it's not accessible.
Right, and so this gets into also. It seems like some of these issues around food sovereignty, where people are participating in the production of food system, maybe in the next counting over, as part of their job, but yet they're still food insecure where they're living.
Right. So
it seems kind of crazy. Right?
It is totally crazy, right? Another example is looking at North Dakota, South Dakota, Wyoming, Montana, Idaho. All those counties that are blue there are producing animals that are being shipped to Nebraska for processing. That's what we're seeing there. A lack of processing facilities near where production is happening.
Okay, great. Well, thanks for those explainers.
Sure.
I'd like to shift gears a little bit now. We'll come back and chat a little bit more, but right now, let's get Patrick up on the screen. And Patrick, we welcome from UC Davis Food Systems Lab and the Institute for the Environment. Patrick Huber also leads the Smart Food Sheds effort at Icicle, and in particular, a new concept that he'll be presenting today is this Internet of Conservation. Patrick, what you got for us today? Take it away.
Hi, Matthew. Thanks for having me.
It looks like you're still in design view there, though. Maybe if
Yep. I'm about to shift it over right now.
Perfect.
Okay. So yeah, I'll talk about smart food sheds and this concept of the Internet of Conservation. So to get back to kind of the problem that we're trying to address that's been touched on already, but when you're trying to plan for landscape conservation, you're talking about a lot of different stakeholders, a lot of different needs, a lot of different desired outcomes, lots of data, but lots of different kinds of data that don't currently fit together. So there's issues with data discovery and access, which data are available, who has access to them, how do you get the data? What's the appropriate workflow for doing some landscape conservation in a particular context? Or even figuring out who should be at the table as part of this process can be difficult, and you can end up with the same people in the same conversations while other groups are being excluded that don't necessarily have access to some of these other things. So, there's difficulties in pulling these together. It's not a particularly efficient process, and there's probably a lot of duplication of effort out there. We're just not looking at an efficient process here. So how can we bring information and social networks together to improve the process and outcomes for planning for landscape sustainability? So the approach that our group and colleagues are taking is a linked data approach. Make the data be able to talk to each other and make people be able to find those data. How do you do that? You can use ontologies, which are formal machine-readable descriptions of knowledge. These ontologies help ensure that when people are using vocabularies, that we understand what those vocabularies mean, that we know what people are talking about when they're using different words, different ways of using language, and to be able to enable computers to read across those different kinds of languages. Ontologies have been around for a little while now. Some of the more well-known ones are things like the gene ontology, environment ontology, and there's a sustainable development goals interface ontology. Now, those are the conceptual structures. When we actually get to a real-world planning implementation exercise, then we'll want to have actual data associated with those conceptual models. So that's knowledge graphs. That's where using the ontology as the framework to hang real-world information off of in a structured way that makes it usable and understandable. So looking more broadly, what is an Internet of Conservation? Well, it's tying together all of the pieces needed for answering or helping answer or at least provide information for negotiations in these complex landscapes. First and foremost, there are networks of people and organizations that have different sorts of roles. They might be decision makers. They could be data providers or users. There's different kinds of partners and stakeholders involved. And so first and foremost, we want to be able to bring the appropriate networks of people and organizations into this formal process. Then there's the Internet of Things for conservation. There's all sorts of devices out there. There are, computer servers that are used for the data, for software. There's sensor networks. There's robots. There's a lot of things out there. So to be able to, we want to bring those in as part of this Internet of Conservation. Linking this stuff together, then we want to have a semantic web of conservation. So that includes these ontologies and knowledge graphs we've been talking about. There are the data sets that are going to be important. There's different kinds of workflows that will be appropriate in different sorts of contexts. Those can be formalized and part of the semantic web of conservation. There's different kinds of websites, all sorts of software. And then you can have finally some AI tools and processes for conservation. So these AI tools can be used for several things. One, to help actually build the Internet of Conservation itself. There's huge amounts of data out there, huge amounts of information to sort through to bring into a structured format. And then once you have a structure built, then you can use AI tools for navigating that information and coming up with important outputs that can be used by the people and organizations. This is a big sprawling enterprise. You can see the colored boxes over on the right. Those are some of the things that our groups have been working on, but you can see that this is going to require not just one group to put together, but this is really what we're talking about is a global effort here. So now bringing the Internet of Conservation to KnowFOODS, and I do have to say that I pulled the Internet of Conservation concept from the Internet of Food that Matthew has been talking about for a number of years. So shamelessly borrowing that kind of concept. But you can see where there's overlap between the Internet of Conservation and the Internet of Food. That is the realm of smart food sheds. You can also think about, going to Michelle's talk, that there could be an Internet of Transportation that fits over this Venn diagram as well. An Internet of Public Health. Different things will intersect in this smart food shed zone that we're talking about. So what do some of the pieces look like that we're using to help build out these smart food sheds? One thing that we've been working on for the past several years, we call PPOD, which stands for People, Projects, Organizations, and Data Sets. And so this ontology is used to understand who is doing what in the landscape. And there's all sorts of important questions that can help get structured here, answers found to help you understand what is going on in a given context. And so this ontology describes the characteristics of these classes of information, the people, projects, organizations, and data sets, but also formalizes relationships between them in ways that are machine readable. And so you can have queries going across this structure. So again, that's the ontology, that's the conceptual framework. We've been working for the past several years to instantiate this ontology with information on California conservation planning. And so this is what the knowledge graph based on that ontology looks like. This is just a small little sliver of the large knowledge graph that we've been developing. We have somewhere on the order of 2,500 different organizations and hundreds or thousands of projects, data sets, programs, people, and things like that linked here. So you can see here that this kind of gold color of box, those are organizations. We have people in the green, different programs that in purple, specific individual projects in the blue, and then roles that the people play in this kind of turquoise color. And so if you look right at the center, you see California Department of Conservation. If you follow the kind of gold arrow leading up and to the left, up to the California Biodiversity Council, you can look over at over on the left, and you can see is a member of. So California Department of Conservation is a member of the California Biodiversity Council. And so that is that formalized relationship between the two organizations. And so you can see that we have this full network that has hundreds of thousands of different links between these different entities. And you can start doing queries to discover information about what's going on in conservation planning in California. Now, to bring this back to Icicle, this started a little over a year ago, and it's going to be providing the support to to help enable the building out of the Internet of Conservation and the associated smart food sheds. So there are, it's an institute that brings together 14 different universities and other organizations, including several supercomputer centers. There's a lot of computing capacity, and so we're leaning on Icicle to provide a back end and repository for some of the ontologies that are getting built, and using that as kind of a keystone piece to help build out the IOC over the coming years. Some of the things that we're working on right now at Icicle to help develop the IOC is, first and foremost, we want to bring in outside groups as use cases to actually make this operational, usable, and useful. So we have some ongoing conversations right now, but we're certainly open and want to form new partnerships and build this thing out. We have several lines of ongoing work, including a visualization platform for doing queries across these knowledge graphs in different ways to provide different sorts of output information. We're starting the process of putting together the potential for doing data federation. So Icicle is not going to be a data repository. What we want to do is be able to point to existing databases that other entities hold and be able to bring them into the PPOD framework, into other ontological frameworks, so that queries can bridge all of these different databases that we're going to bring in. And we're also at the front end of developing conversational AI querying capacity, so that you don't need to be a programmer to access these knowledge graphs in a useful way, but you can just use natural language and have the AI agent come up with information from the knowledge graphs to help answer your questions. And then finally, here in the next few months, we're going to be deploying a public-facing access point, specifically through IC Foods, to begin accessing these data and tools that are being developed. So definitely look for that. Go onto the IC Foods website this spring, and you will be able to access these knowledge graphs and other things that we're working on at Icicle. And so I think I will leave it. Well, I should acknowledge some of the different funded projects that have enabled this. Some NSF funding for an open knowledge network, a research coordination network, funding for Icicle itself. And then I would like to acknowledge Icicle and the many researchers and students and others that are enabling this to all happen. So I will leave it at that. Courtney, you're muted.
Try again. So let me start again. Let me just say, wow, Patrick, that was a great presentation. And clearly there's a lot of different parts that are moving simultaneously at a whole bunch of different scales. And I know you've essentially been working kind of on this, the components to be building the Internet of Conservation for a long time. Of just kind of recently giving it an identity that's separate from the food piece. And Smart Food Sheds is clearly that overlapping piece, but how much do you think the kind of the cyber infrastructure and those core pieces are going to be very similar, and what kind of additional things do you think that kind of each piece of the pie are going to need to develop from what you've seen so far that are kind of not the same? So if that makes sense, like, you know, there's a core cyber infrastructure piece that's going to be driving the whole organizational platform and tools and things like that. But what are some of the things you think for this conservation side that are still missing?
Yeah, so you're right. There's a lot of pieces that are going to be used by both the IOC and the IOF. The PPOD ontology, for example, is going to be universally useful ontology, kind of across domain, to be able to understand who's doing what where, why, where funding is moving from. Those are all important questions. There's going to be other kind of similar ontologies that could be useful as well across these realms. But there's going to be individual specific things. We'll need to tie in the Internet of Conservation to either existing or to be developed ontologies describing species, describing ecosystems, describing natural processes that aren't necessarily of high relevance to the food side. And similarly on the food side, there's going to be things like describing nutrition, different ways of moving food around the landscape that aren't necessarily of high relevance in the Internet of Conservation. But what we want to do is develop those ontologies, those knowledge graphs, in a way that they link together and will, if queries come up, allow you to move back and forth between the IOC, the IOF, and move up and down in spatial and temporal scale.
Excellent. Well, we have lots more questions, but why don't we invite everyone back on screen and we got everybody? Great. So and then I think you already mentioned, so the Internet of Things is clearly an important component for kind of that original data collection piece that's feeding in. How much is already connected, and where are you seeing kind of the biggest gaps at this point that are kind of the next thing to be approached?
Let's start with Michelle.
Oh, with Michelle. Okay, for both of those, where are the biggest data gaps?
With somebody.
Real-time data.
I am constantly amazed at how much data the transportation sector has. I mean, it is unbelievable. And it's just all disconnected. Every state has at least one person who does nothing but freight planning, and they don't have access to, they're using somewhere between 8 and 10 different databases and trying to make sense out of it. And each individual DOT freight planner is doing that separately. It's insane. So, and I think there's also a whole lot of opportunity for linking some of the financial information. A lot of economists, I think, are accustomed to doing some modeling and working with data. But as far as I know, there isn't any kind of ontology of, goods movement and financial information. And of course, a lot of that will be proprietary, but I think there's also a fairly good, the census food flow data has financial aspects tied to it as well. So connecting the nutrition, the social networks, and some of what's going on with food production, I think all of those things are really exciting to me.
Patrick?
Yeah, I'll jump in. So in the world of conservation, some of the important things that are out there collecting data are camera traps, looking at where animals are moving across the landscape, getting images and getting a sense of how individual animals move, as well as what the dynamics of the overall populations might be. There are a lot of animals out there that have GPS collars on that are tracking movements. None of this stuff is tied together in any way. So there's all of these many different little repositories of information on how things are moving across the landscape, how individual animals are actually using the landscape. Luckily, I can say that at Icicle, in addition to smart food sheds, we also have an animal ecology team and a digital agriculture team. And so they are working as we speak on camera traps and drones and bringing the Icicle infrastructure to be able to intelligently parse information that's coming from those things. So I hope to bring that into the Internet of Conservation here before too long.
Great. And what I'm going to flip it right back to you, Patrick. For this Internet of Conservation concept, what does this look like in 5 years? Where do you think we'll be in 5 years? And will people be able to engage with this? What do you see as critical elements here?
Critical elements right now are building up enough of a library of use cases to start building this thing out in a modular fashion that really goes beyond just what one particular team can do. Like I alluded to, this is really a global concept, and we'll need a larger mass of people that are buying into this as a concept and enabling interoperability between what they're doing and the pieces that we've built. And I think the key to that is just building up momentum to bring in individual use cases. I think that once some people start really using this, that the ball will start rolling and it'll get built out. So in 5 years, I don't have any sort of exact number, but hopefully we'll have a number of use cases ongoing with publicly facing websites, ways for people to engage in the IOC.
How about you, Michelle? What does success look like for you in 5 years?
Or I don't know if it's 5 years or maybe a little more than that, but one of the things that excites me is this idea of a foundry. There are so many people creating data and information that could be loaded into a foundry if they knew what a foundry was, if they understood what an ontology is. And I think we're just a few steps away from that. So trying to figure out what it's going to take to build awareness of that tool and do the basic training necessary to participate in it, that's extremely exciting to me.
So what I think I'm hearing you both say is that we need essentially 3 key elements here. We need political will and buy-in from stakeholders. We need a mechanism for cohering all of these disparate data sets so that we can connect them, and then we need to train people to be able to use those technologies. Would that be a fair assessment?
Yes, although on the third point, I think that we also need to improve the technologies to reduce any sort of training time to make it as easy as possible to access.
So lowering technical barriers to entry, would you say?
Exactly.
Well, that's almost a different category of people. You have people that are building the technologies, but then you just have a broad base of people that want to use the technologies, and they don't have to know how it works. They just need to be able to use it.
Correct.
So back at you let's start with you, Michelle. What does the food transportation planner's job looks like in 5 years? What do you see them being able to do that they can't currently do? Maybe not 5 years, but once these technologies take hold, what do you see the kinds of questions we'll be able to ask and answer that we can't currently?
Well, one of the things that I'm hoping we can do is at very minimum get these maps made on a regular basis so we can see where there's a concentration, basically a bottleneck in the transportation system and the food production system. We don't have the information on food flow now doesn't really link properly to the information on where things are grown. So for instance, we know that there's a number of people are cutting down their deciduous or their fruit trees and their avocados and almonds. How does that affect the overall flow of food? We don't know because we don't have a connection to those data and the food flow information. And because the food flow information right now is really only a census every 5 years, we don't have a way to connect it with the more current information we might have about how trucks are actually moving perishable goods across the country every week.
So live updates maybe, and being able to ask and answer questions from closer to real-time data. And
I also
being
think
able,
it would
yeah.
have a really big impact on policy if people could see what was really going on, right? So a planner's job is to try to take all this information and turn it into something that makes sense to a policymaker who's going to provide money for, infrastructure development or, programs that will change, improve the situation for people. And given climate change, we've got a real need to know how things are changing and closer to real time.
And Patrick, how about you? What's a conservation planner going to be able to do that they can't currently do?
To keep on the food theme, we can think of a planner being able to ask questions like, if I'm doing a forest restoration project or a restoration project somewhere, where can I maximize biodiversity outcome at the same time as providing resilience to things like forest fire or flooding that could impact the transportation network and food flows. How can I really maximize all of these different outcomes that aren't linked currently, from across the natural systems, the human systems. And right now, we don't have a way for those systems, those data in those realms to really talk to each other to be able to answer these kind of causal queries.
Just to piggyback on that and maybe give a tangible example, because it seems like all of these questions are coming into play on some new projects that are getting kicked off the ground. A question might be to minimize potential for fire impact, where do we need to add more grazing, right? But if you add more grazing, do we have the transportation and the food system support to make that a viable business opportunity for those producers? So it's pulling these pieces together. And the grazing question is one that pops up pretty regularly, and we know that that's especially in the West, the arid West, it's going to be a question that keeps recurring.
So, what are your immediate next steps, Michelle?
Oh, I'm still working on figuring out what all the things that went down last week at the transportation conference. I'm hoping to have a conversation with the Bureau of Transportation Statistics about using our smart food sheds work as a case study. This might give us some access to additional funding so we can actually pull off some ontology development. I think they might be really interested in the food flow down model that downscales to the county level, because that's another issue that they really want. I'm also going to make some overtures to the people who are doing AI for freight planning to see if we can't engage some of those freight planners in a review of the work that Icicle's done thus far on visualization. We want to see what they think. Are these the kinds of visualizations that are useful to you? Are there other data sets that are helpful? What do you need to know as a freight planner to be able to fulfill your responsibility every 4 years to provide the federal DOT with a plan?
Great. And Patrick, what are you doing to make this happen tomorrow?
I think an important thing that needs to happen over the next 6 months, year, is engaging with more of, especially the state agencies here in California. There are some large scale ongoing processes that I think could really benefit from taking an Internet of Conservation approach, something like the California 30 by 30 process, for example, which is a subset of the national and global 30 by 30 efforts, which is to protect 30% of the Earth's or California's ecosystems by the year 2030. Among other things, it's a large information kind of effort and organizing all of the different, who's doing what on the landscape. So I think that those are ongoing, and there's a lot of opportunity to really engage in those efforts over the next year with the resources that Icicle has and the Internet of Conservation.
And one final question for each of you, and since you're already on screen, Patrick, I'm just going to start with you.
Yep.
What do you say to folks who who sort of push back and say, well, it's my data, it's my business. It's should be private. It's part of my secret sauce for my business. You don't necessarily need to have access to it.
I say that's fine. If you want to keep your information private, then keep it private. But publicly accessible data will be organized through this platform and tie into it, to help out with your business and anything you want to make publicly available will have the infrastructure to do that. But this, our effort is not to make private information universally accessible.
And Michelle, how about at your end? When we know that transportation data can be quite valuable, and people can see who their competitors are, especially if there's not that many of them. What do you say to folks who say, leave my data alone, kind of?
I really think there's a case to be made for aggregating data and hopefully, removing some of those things so that those information tags, so that more people can access it. I think there's a new program at the national level called Flow. It's about freight logistics optimization, and it's being used at the ports in particular. And the way that they're handling some of that is that if you want to know what's going on at the port as a whole, you have to be willing to put in data, and then you can access the aggregated data and get a sense of where you stand as a business. I think the same thing could be done in food. And, it's a little different. Transportation is different than food in my mind, in that food is a human right. And so, we need to know what's going on with food, who's not getting it and why, and what needs to be done to fix that. And that's a public logistics issue as much as anything.
Great. Well, I think we are approaching the witching hour here.
I think we are.
I'd like to thank our guests, Michelle Miller from University of Wisconsin and Patrick Huber from University of California, Davis. Great informative chat, and we look forward to more.
Yeah, what a great conversation. Thank you all for joining us. And before we close, just want to invite everyone in our audience to join us again next month, third Thursday in February 2023. And then don't forget, this and all of our previous episodes, you can watch whenever you get a chance. They'll be streamed on our YouTube channel. So hope to see you there. Give us a like when you watch it. And thank you again, everyone. Bye-bye.
Bye.